Hello and welcome to another Redbex training video. In this video we're going to talk about spatial data and spatial support in Redbex. So let's do first a little reiteration and think about where actually do we need spatial information in Redbex and where do we use it. Therefore I would like to show you a little part of our Redbex manual which you can find online, and there we see there is a chapter which is all actually called Spatial Data, and there we can see where do we use spatial data in Redbex. You see there is a special kind of spatial data support. The spatial data support actually is in connection with features and the observations of the features. So features and observations, both of them could have spatial data support. So we have three different types actually of spatial data support. There could be of course no spatial data support at all, which means neither the observations nor the feature itself allows to store some spatial data. Then we have spatial data for features, which mostly is connected with this abbreviation SSF, as we will see later on in the Redbex client itself. This means actually the feature itself does have spatial data support, but not its observation. This, I would say, is the most typical way. For example, if you think about a temperature sensor, then this temperature sensor of course would have a location, so the feature itself would have a location in Redbex, but the observation, the actual measured temperature itself, would not have a location, which would mean the location would not change on the observation, so therefore the observation itself does not support spatial data. And then the last one would be a spatial data support for the observation itself, and there you see this will be used if the observation itself includes the spatial information. For example, if you have some deer watching, whatever, if you have some GPS tracker which you would like to cover with a feature, then the feature itself, the observation of this GPS tracker would not have a location, but the observations itself, they would have a location, and so therefore the location would be stored with the observation. Let's have a little look to our Redbex client and just see how these different types of features and the different types of spatial data support would look like. Therefore, I just created two different kind of the feature of this. The name is a generic numeric, and we have the generic numeric features in two different editions actually. The one contains spatial data support for the feature, and the other one contains spatial data support for the observation, and there we see this abbreviation at the end of the name of the feature type here. So right now I opened the feature type which has spatial data support on feature, abbreviation SSF, and you see at a glance that in the base data, in the first tab, you see there is a section already with the spatial data already entered here. So this feature already has a location, it supports spatial data, and we can see the spatial data in the base data. If you have a look to the observations of this feature, then you will see the observation just consists of a numeric value. I like to switch to the other view. Then we can see that the base data is just the sampling timestamp and the resulting timestamp. Then we have also this erroneous flag to be used. There is no sensor defined actually, and the only value which is within this observation is the numeric value itself, but there is no spatial support for the observations here to see. Then let's switch to the other one, which is the generic numeric feature type with the abbreviation SSO at the end, which means spatial data support on observation but not on feature itself. And there we see, in difference to the base data for the first feature we opened, we have here spatial data support, but on this one, on the SSO feature, there is no spatial data section here. Spatial data is missing, is not supported for the feature itself. But switching to the observations of this feature type, I like to switch to the single view of the observations because I like it more. Then we see again we have the base data here. We've seen this on the other feature type also, but now we have also a spatial data section on observation. So every observation also is able to hold a spatial information here, and afterwards we have the value which could hold any numeric value, of course. So this is the difference between those two features, but we are not talking about spatial data support. Actually, we did this in a video already before, and you might remember we did this in connection with this shape definition window. This allows us to actually give a location to a feature or to an observation, but this, as I told you, was done in a different video, so we won't dig deeper here. But what are we going to do in this video is to talk about in which systems actually these numbers here, these coordinates are interpreted. So which support of reference systems does Redbex allow? So in general speaking, there are three different types of spatial types of spatial systems. So there are three different spatial let me think, the spatial system types. I just looked in the reference manual and would like to show you also, because there you can find again in the section Spatial Data, you find there is a section Spatial Systems, and there you see we have three different types of spatial system types which are supported by Redbex. We have at first the geographic system, then we have the projected coordinate system, and then as a third, which is a little bit different, we will see there's also the axis reference system. So let's first talk about the geographic and the projected system. You might of course know the difference between those. In the geographic system, we have a system which covers the whole Earth, so we're talking about reference systems for the surface of the Earth, and we have just here named one 0 latitude and 0 longitude meridian, and we just count the numbers here. We're just talking about degrees, and so every point of the Earth is referenced by a pair of numbers, a pair of degrees, which have the benefit that the whole Earth is covered by these systems. But we have the problem that the system is not linear, because if you think about the distance of those two longitude lines here, they of course are much shorter than the distance between those lines on the equator. So we have to think about a different system if we would like to have a linear system, and therefore we use some projections. So we try to project the coordinates on the Earth to a two-dimensional surface, which then can be used in a more handy way. And we have quite different types of projections. We can use some cones, we can use different types to project the coordinates to a two-dimensional surface. And if we do so, we have the benefit that we have almost some coordinate system we can use in a quite a handy way. Then for the third, I will just show you how it works on an axis reference system. Let's say we have here some mountain, and there would be a tunnel to be driven. Then there is a definition of a tunnel, which is this line here. You can see here in this case, and the line is defined by a number of 3D points, and then we set one of these 3D points. We define this one as the origin, and we also define a direction, and we call the origin and the direction an axis reference system. So we just need an offset to define a point on this axis in regard of this axis reference system. So let's have a look to the Redbex client again to see where these types can be found and the spatial reference systems can be defined. I didn't mention before, there is also one other reference system we have to take into account, which actually is the vertical reference system. So we have here in the common ribbon, we can see we have the coordinate systems, which cover the systems which cover the surface of the Earth, and then we have also the vertical coordinate systems. And if you have a look to, I have provided here something for you. I think it is no, just 1 minute. If we look to this picture here, you see here different vertical systems, which is a reference to the height of the sea, actually to sea level. And in this case, the base sea level is here in Denmark. So this is the base reference system, and every other reference system actually has some additional value which should be added or subtracted. For example, here you see in Italy, they have another different vertical system. So in regard of Denmark, we had to subtract the value 30, and if you look, for example, to Great Britain, then we had to add a number of 5 to the reference system in Denmark. So let's have a look to the vertical coordinate systems, which actually are quite easy to define. We have here 3 different coordinate systems already defined. So let's have a look to the first one. This is the, let's call it the base vertical coordinate system. I can't edit it, it's already entered. There you see here it's not changeable. Then we have generic depth defined here and the generic height. So if we know the difference to the coordinate system I would like to use, for example, let's define virtual coordinate system Great Britain. Then, as we have seen before in this map, if we take into account we are taking the Denmark coordinate system as a base, then I should add here a value of 5, and I just add here the conversion constant of 5, and maybe I give a document description that this is in reference to Denmark's virtual coordinate system. So we just define one as a base, and then we just had to enter this conversion constant to clarify if we just have, if we would like to work in another virtual coordinate system. And if we have some very weird, strange coordinate systems, we could also enter a conversion factor here, but this usually should not be needed. I just keep it as it is, so I don't need any other vertical coordinate systems here. And now let's switch over to the coordinate systems on the surface. We have seen already before we have 2 different types of coordinate systems. Ones are the projected, and the basics. The basis of the projected coordinate systems are the geographic coordinate systems. Therefore, we have here 2 pairs of buttons. The first ones are to add either a geographic coordinate system or another projected coordinate system, and then we have the possibility to switch on and off within the list beyond if you would like to see the geographic coordinate systems or the projected coordinate systems. So for example, I switch it off, this button then I see only geographic coordinate systems in the systems, and if I click the other one, I see only projected coordinate systems. So now let's define one coordinate system. I will start with the geographic coordinate system. This is the more easy one. I can give it any name, of course, and some description. And then I have just a big list of vertical coordinates of horizontal coordinate systems here, and I just would have to look for the coordinate system I would like to use. I just take any right now. Then as an information I see already the project 4 definition for this coordinate system, and I also have to define a vertical coordinate system, which means a spatial data a reference system in Redbex always has to combine a vertical coordinate system with an horizontal coordinate system. So I have to enter this one. This is in meter. Let's take this one. So my projected coordinate system, my geographic coordinate system right now would be defined. Let's give it a better name, and I can save it right now. And if I refresh this list, I should see it already here in the list, and now this can be used within the Redbex system. Now for a second, let's define a projected coordinate system. Therefore I press the third button here, add projected coordinate system, and now here I see I again have to define a vertical coordinate system. I again take the height in meter, but I don't have any drop down for my for the projected coordinate systems I would like to use, because there are quite a big number of different coordinate systems. And to select the coordinate system, I would suggest you to go to the page I will show you in a minute. It is the page spatialreference.org. Here it is, and here you have the possibility to get really a big number of different spatial reference systems, and also the project 4 definition which you need to define it in Redbex. For example, let me search one which is in connection with Austria. I just take the first one, and then I see we have here the coordinate system EPSG 3416, and if you see here on the right side, you can see that this is quite optimal for Austria. So this projected coordinate system is designed to be used for points within Austria. So now I need the project 4 definition for this coordinate system, and you see here there's quite a different number of definitions, and I take the project 4, and now I have just to copy this line and enter this line in my project 4 definition here. I give it a linear unit which will be meter in my case, and now I call this one Austria. And it is always a good idea also to keep this EPSG code here, because this is quite unique and quite speaking, and so I will give it the number here in this field additionally as an information. Now I save this coordinate system and I refresh this list, and now I have also my Austria system, my coordinate system for Austria, defined in Redbex. So the last question is how to define the axis reference system. This is done not within this ribbon. The axis reference systems are much more bound to projects, because axis of course have a very strong connection to a project, and these coordinate systems don't. So the coordinate systems for the surface of the Earth are defined on a much more general level than the axis reference system. To define an axis reference system, we go to the data domain, which is the place to help us to define this kind of metadata, which will be defined within for one project. And there we find, if we right click the data domain, there is some section which is axis. We see there's already one axis defined. If I would like to define another axis, I just press the plus button here on the top, and then I get a new axis definition. I give it a name. This is my new axis, for example. I can also give it a description to give more information for this axis, and then already I have to define in which coordinate systems these points, these numbers, which I give afterwards to define the axis, should be interpreted. And then I define, for example, this should be in my Austrian projected coordinate system. If this axis is not the whole axis of the whole defined axis, which usually is the case, because you just need the part of the axis where your project is situated on, then you just define which offset the first point of the axis you import will have. For example, in my case, I could name the first point already is 1200 kilometers away from the origin. And now let me show you how this axis actually will be defined. You can see this also in our reference manual. If you just open up the reference manual, I will do it for you. Here it is. Then you see there should be some example for the axis. Here it is. Then you see an axis import file just has different lines. Each line is one point of the axis and just numbers of points in the line. And I have provided one file like here. This is my axis. You see this is quite a big number of points, so it's quite a long axis. And to import it, I just use the client itself, and I have to use also the file depot to get the X definition to the Redbex server. Now I open the axis here by just adding one file. My axis is called simpleaxis.txt, and then I already have it on my server. And I save this X definition once, then I have the possibility to open this import button here, and I just drag the axis definition file to my definition here, and it's imported quite quickly. I can see the points on the second tab here. You can see here all the points which have been imported, and in the third tab you get some visualization of the axis here. So now we have an axis, but the axis alone is not yet our axis reference system. We have to do a reference system also. I refresh this to get the other axis too. To add the reference system, you just click this context menu here and call up the reference systems window, and here you just define, for example, this should be drive north. The origin offset, as I told, the axis starts with 1200. I can define here, for example, the origin of this drive is also 1200, and it's not inward direction, so it goes just along with the axis points, and I don't need any conversion factor. This would be needed, for example, if the axis is given in a different unit than we use within the drive itself, but here it's the same, so I keep the conversion factor 1, and there will be no additive constant. One information which should be given in the definition here is the expected length. So for example, I tell the system this would be 500 meter, then Redbex has the possibility to give to tell you in the start page how much already has been driven for this drive. This can only be done if the expected length has been entered, because then I can tell, for example, 1/3 already has been driven. So save this reference system, and then I have another axis reference system which is based on my axis I just defined, and it can be used within Redbex. So now let's see where actually I use these reference systems, these three different types of reference systems we defined now. Well, of course, we know from the first video, if I create a feature, then I have to select a spatial system. And these spatial systems which are available here of course differ of the feature type. So not every feature type can be based on every spatial system. For example, if I would like to create an axis position feature, then this axis position feature only has the possibility to be based on a spatial system which is an axis. So I have to call up axis type, and then I can select different spatial systems, reference systems which are defined on axis type. If I change to, for example, a 3D movement feature type on the surface, then we will see that this one gives us only the possibility to define a spatial reference system which is based on the type projected coordinate system. So the feature type gives the possibilities of coordinate systems which can be used. So let's, for example, give a more general feature type, temperature. Then we will see this one now gives us the possibility of every of these three types which are available in Redbex. So a temperature sensor can be located using different types of reference systems. So for example within tunneling, which within axis bound reference systems, and also which on surface reference systems. We have also the possibility to change the definition here. For example, if I open this feature I already created before, then I will see that this feature is created based on a projected coordinate system, which is the WGS84, and I can also see there's some vertical system defined on generation of this feature. And if I happen to have to change this definition, then I can do it by using the context menu of this feature, and then I have the possibility to change the spatial systems. Of course, the change of the spatial system again has only the possibilities which are defined in the feature type, so not every change would be possible. And here, as this is again a general feature type, this generic numeric feature type, I can change here the based spatial system to whatever I would like to. So here this, for example, changes my based spatial type to WGS84. It's important to know that not the values which actually are saved, already stored to this feature type, to the feature itself or to the observations, will be converted. They just remain the same, the numbers will be untouched, but only the way these numbers are interpreted, so the spatial system which is used to interpret these numbers will be changed. Another thing I would like to show you is the location converter, which gives you the possibility to convert the location which is given in one spatial system, in one spatial reference system, to another reference system. For example, let's tell I have one coordinate given in WGS84. Then I just copy the values from my source of this point here, and I just define where I would like to have these numbers converted, and then this location converter will just display the point and convert also the coordinates to one coordinate system to another. Of course, the conversion of coordinate systems is also bound to some restrictions. Therefore, again, I would just suggest you to open our reference manual. There you will find a chapter for transformation of spatial data, and then you see there are some restrictions which are listed here in this table. And also you will find some information about changing the reference system. Also there are some restrictions which should be regarded, and you will find them here in the reference manual, and I will just suggest you to have a look to the reference manual to get all the information you need to work with spatial data and spatial data support and spatial systems in Redbex. Thank you for watching.